The check engine light came on, so I decided to investigate the issue. I connected a scan tool to the vehicle and found code P0335, which indicates a problem with the crankshaft position sensor A circuit. To better understand what was happening, I used the scan tool to monitor live data while the engine was idling. I noticed that the crankshaft position sensor parameter was behaving erratically, which confirmed there was an issue. Next, I conducted a thorough inspection of the crankshaft position sensor wiring harness and connector, looking for obvious faults like damage or loose connections, but I didn't find anything out of the ordinary. To dig deeper, I decided to test the sensor's signal directly. I backprobed the crankshaft position sensor, connected a lab scope, and monitored the signal while the engine was running at different speeds. The signal displayed on the lab scope was inconsistent and irregular, confirming that the crankshaft position sensor itself was faulty. To address the problem, I replaced the crankshaft position sensor with a new one. After installing it, I cleared the fault codes and performed a road test to ensure the repair was successful. During the road test, the vehicle operated properly. The check engine light stayed off, and no fault codes reappeared. This process was important because the crankshaft position sensor plays a critical role in engine performance. It monitors the position and rotational speed of the crankshaft and sends this information to the engine control module, ECM, which uses it to adjust ignition timing and fuel delivery. A faulty sensor could lead to poor engine performance, misfires, or even engine stalling. By replacing the sensor, I ensured the engine could operate efficiently and reliably.